The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and good morning, everyone, depending on where you are tuning in from. I am just doing a quick sound check. If you can hear me and see the first slide on your screen, please use the raise hand icon to let us know that you can hear and see what's on your screen. Perfect. And we will start the webinar at 1 p.m. Eastern sharp. Hello, everyone. My name is Therese Kasongo, Program Manager with the Canadian Institute of Plumbing and Heating. Welcome to the webinar on Application for Smart Water Management in Commercial Buildings. I'm delighted to note that we have 139 sites registered across Canada for today's session, which is really great. Before we start the webinar, please note that you will have the opportunity to ask questions at the end of today's session. You can do this by typing your question directly into the question box. The question box is located in the webinar control window on the right-hand side of your screen. Please save your questions for the Q&A portion at the end of this session. Also note that a recording of today's presentation will be made available to all attendees following the webinar. And you will also have the opportunity to submit questions after the session has ended via email. Please join me in welcoming Avishai, who will be doing a quick introduction of today's speaker, Adam Bartman. Avishai, over to you.
Thank you very much. Hello, everyone, and welcome to our application for smart water management in commercial buildings session. I am your host, Avi Moskovich, CMO here at Reed. We do absolutely encourage you to submit any questions during the sessions, and we will answer it at the end. And with that being said, I would like to introduce you to our presenter today, Adam Bartman. Adam is a solution architect and a co-founder at Reed. Adam supports partners and engineers with advice on how to design connected water applications to benefit their project. And with that being said, Adam, please take it away.
Hey guys, thanks so much for joining us today. Super excited to run through this deck, and thanks to CIPH for hosting us today. So we'll go through this deck in sort of 3 sections. I'd like to spend the majority of the time on section 3 because I think it'll bring the most value to the audience today. Section 3 is really going to take a deep dive into some very technical applications on the domestic plumbing systems. But before we get into the applications, for me, it's always important to give sort of an introduction and explanation on the current environment and some of the issues that building owners are facing currently. So if we had to sort of give a preface to this entire presentation, when we look at the market, when we look at domestic plumbing systems in commercial buildings, it's clear that there's going to be, in nearly all cases, 3 primary mechanical systems. We'll have the HVAC for heating and air, we'll have the fire suppression system, and then of course we'll have the domestic plumbing system. Now what we're seeing, regardless if the building is new or old, small or large, that the HVAC systems are typically well connected. Either the appliance is so smart itself that it can self-regulate and provide some information and data, or in a larger, more sophisticated building, they'll have some form of building automation or BAS. Next in line is, again, the fire suppression system. Just naturally, due to regulations, those are always connected and monitored, and fire department, etc. But when we look at the domestic systems, time and time again, we find there is no relevant platform to make any kind of connectivity when it's imperative that building owners have information on consumption, pressures, temperature, and flow rates to make sure that their systems are functioning properly. And so we'll take a look at, again, the specific portion of the market that's struggling with this item, and then some of the ways it can be elevated into a better arrangement. So the real takeaway from today, again, kind of following these three segments, would be to be able to explain some of the challenges that building owners face, some of the conditions they're experiencing, primarily because these domestic plumbing systems are unconnected. To then understand how an IoT technology or solution can be applied here to really push forward the current domestic plumbing design strategies or standards. And then lastly, be able to recommend real life applications or solutions that will really provide building owners a ton of value and really optimize the properties and step into that the direction we're heading anyways when it comes to smarter and more optimized commercial properties. So as we go through this, you'll notice some of the text is a bit small. I wouldn't worry too much about reading into the details. As our hosts have mentioned, we'll share a recording and the actual document itself. I would just pay more attention to some of the headlines, and then of course I'm going to go over all of the items one by one. And so for section one, it's really about exploring what technologies are available and specifically which markets are really underserved. And so we've come to this term of the mid-market. If you lay out all the different asset types in a very simple linear format, on one end of the spectrum, you're going to have single-family home. In the last 5 or 6 years, we've all seen smart home technology really take off from some of the giant tech companies. And so we see today that, particularly when it comes to water and conservation and leak detection, that the single-family home market is very well served. There's a number of vendors and providers that have focused, their equipment and technology for the single-family home market. On the other end of the spectrum, as I mentioned earlier, you're going to have these Class A, the glass tower downtown, where they may have 8 or 9 operators and deep pockets, so they can afford, a very sophisticated building automation system. However, it's interesting, we still see that they're not being applied to the domestic systems, and we'll get into some of the reasons why, but it's very common that even in the Class A buildings, items on the domestic side are unconnected. However, fair argument to say that the system could be manipulated or expanded to solve some of the challenges a Class A may face. Where we really focus, and where the general presentation today is going to focus, is again on this mid-market, and that's really everything between those two. Again, a very underserved market. That's everything from a big box store, freestanding building, all the way to a 50, 60-story multifamily building, and everything in between that are really struggling with some of the operating conditions post-construction that ultimately degrade, the plumbing system and therefore the building, and creates a very uncomfortable environment for the building owners and the occupants. And so some of the questions that we ask ourselves intuitively, the first here obviously being, what are they trying to solve? What challenges are they having? And so when we speak to clients in our market, they're typically trying to solve one of these three things, at least, sometimes all of them, but it's been kind of well categorized into these three buckets. And so the primary things that we see building owners trying to solve, their need, so to speak, is improving the day-to-day workflow. So if you imagine in a larger commercial building, mid-size office building, water shutdowns are pretty frequent, and a lot of the service providers that service these buildings are really struggling to find shut-off valves, find valves that work because things haven't been exercised, having challenges around bad storage temperatures, too high of flow rates. And so a lot of this stuff could just be made much more seamless if they just had a bit of information data and then the ability to control autonomously these conditions. The next item in line, and the one that I find most interesting because it creates immediate value for a lot of these asset types, is around conserving water. I know in our market, the cost per cubic meter is extremely high. I suspect in some of the the warmer states that water rates are in relative cost. But the idea here is being able to implement some kind of solution or technology that provides them a little more information on how water is being used in the premise. A lot of buildings, particularly larger ones, will still only have one incoming water service from the street with a meter that's typically there for the municipality to do their billing. But really beyond that house meter or bulk meter, as they say, there's no information on how much water is being used at a certain wing or on a certain line. And so just having a next level of granularity into water use really frequently allows building owners to create a water conservation program. And then the last, and maybe a little more obvious when we're speaking water, is about managing risk. So how do we stop the major flood from becoming just an absolute disaster? A lot of times that the reason these floods become so damaging is simply because it takes too long to close water. And so having something simple like the ability to remotely close a valve quickly and obviously off-site could really mitigate the exposure for a lot of these building owners, avoid the tenant disruption and all those scenarios that come with. So these are typically the three things that building owners are really trying to solve. A little more specifically and more into some of the design standards. Again, I spent about 15 years in the plumbing industry, owning and operating a service company for commercial buildings, and day in and day out, we see building owners struggling with system conditions, temperatures too high, flow rates too high, pinholes, leaks, and all the stuff that comes with. And it's frustrating for service providers to know that these are typically simple things to fix, but without any kind of data, information, visibility into conditions, of course, they're just going to go unnoticed. And so, I've thrown up 10 items that were quite prevalent in our client base. Certainly not limited to just the 10, but in certain buildings that have pressure reducing valves, they malfunction. You begin to get imbalanced pressures and temperature delivery. Seen a number of times storage tanks where the hot water is being stored far too low, at 120 Fahrenheit, and then you have the risk of Legionella. And there's so many things that just happen, again, due to these unconnected or really unmanaged domestic plumbing systems. And this whole presentation is really to try and push the storyline forward on improving this basic controls in a building, much like you have seen on the HVAC side, just to have a relevant platform to provide the same kind of value. Now, another question that tends to come up quite frequently, either from a client or from the designers, the engineers, is when's the right time to recommend or implement some kind of new technology into a building. And so we've kind of categorized it into three times that these can be implemented. Of course, in a new construction environment, it's going to be quite easy. It would just be embedded into the design drawings, either a small application or a wide application. What's nice in the new construction environment is that the labor is really neutral. I mean, to have an example here, a manual shutoff valve on a domestic system, or an electric, actuated shutoff valve on the domestic system, at the end of the day, a valve's a valve, so the labor doesn't really change. All you're really paying, or the client is paying more for, is the control application or equipment that would be used to operate the valve, of course. And nowadays, with the reduction in technology costs, our phones are so powerful, they should probably cost $1 million, and of course they don't. And so that small delta in cost difference is very quickly made up for in some clever ROI calculations, improvement to workflow, conservation of water. I mean, these things are very easy to justify. And so again, in a new construction environment, very easy to build out any kind of connected system. Now, the other two scenarios are more on the retrofit, and they tend to be more frequent because a building owner who's operated his building and experiencing issues is a little more aware and sensitive to those problems, and so likely more willing to implement some kind of technology. And the only real difference between number 2 and 3 here is again timing. So number 2 is a solution that could be put together using available IoT equipment and sort of configured in a way for a particular asset that we know, will provide value. And I'll give you an example. If you configure a solution in a certain way to promote water conservation for multifamily buildings, we know that multifamily buildings struggle with high water use, or particularly water waste. They have malfunctioning toilets and cooling towers that are running on and no idea what's going on. And so you can kind of pre-engineer or pre-package a solution and just kind of cast a net into a number of buildings. And the majority will again appreciate and acknowledge that they do have this issue and move forward with some kind of solution. Number 3 is just simply if somebody's already anticipating a major capital improvement, maybe they're doing a repipe or a boiler room retrofit, they're in a mindset of upgrading. And a lot of times when you pair one solution with another, overall the ROI may be reduced. There's labor costs that can be shared. And so it's another good time to again make a recommendation to consider a better arrangement. I'll give a sort of light example on that one. We find frequently when people are doing booster pump upgrades that if you were to equip the building with these water monitoring sensors, again, as I mentioned, you can really reduce the overall ROI. Let's say the pump has a 3.5-year ROI or payback, and you apply the water conservation equipment. Now you're saving energy and water. It usually slashes it by a year or two. So it makes a lot of sense in this environment. And so again, this is about timing. You don't want to make recommendations for somebody to implement a couple $1,000s of sensors or solutions when they're totally not in the mindset to do so. Now, to give kind of 2 examples, when I mentioned the mid-market, just to kind of paint a further picture of the types of properties that we're talking about again. And so on one end of the spectrum, a smaller building, we're looking at maybe a commercial plaza. And so in the previous slides, I've talked about needs, opportunity, the timing, and this is really about bringing up now some of the roadblocks and the reason that we're not seeing any kind of solutions being implemented. And so if we look at a commercial plaza, as the photo shows here, just imagine a strip, maybe 8, 10, 12 units, single story. We know that a lot of the landlords and asset managers that are dealing with properties like this, frankly, are not interested in managing risk or leaks, and the tenants have their own insurance and it's not much of a concern. There's no multi-story type of damage that can occur. So, from a need perspective, risk mitigation is quite low, if it's even there at all. But what they're really looking to do in most cases that we find is conserving water, and more importantly, being able to bill for it accurately. A lot of these landlords, that we see. They may be guessing, how much the bills are. They may reconcile annually. It's not a very efficient way of billing for utilities. And so, when we look at the opportunity or the timing when this can be implemented, in a commercial plaza, I mean, it could really be implemented at any time. There's traditionally wide open ceilings or easily accessible domestic plumbing systems, but time and time again, we're seeing the real roadblock for them is due to cost. And so, and again, until nowadays, with these lower cost solutions, their only option before may have been some kind of BAS system, building automation system, that could read a revenue grade meter. And that's why we're clearly seeing this doesn't happen, and it's really cost that is their roadblock. If we look at a different asset type, multifamily building, low, mid-rise, 5, 15-story building, the needs, of course, will change now. So, leak detection certainly something to consider, but we actually find that water conservation is, by far their most important item. And it's really because, these multifamily buildings are simply valued on their performance. And so if you can increase rents and drop operating expenses, then the building's performance looks a lot more interesting. And so being able to control and even reduce a variable cost like water is quite important to them. And as I mentioned earlier, time and time again, we're seeing these multifamily buildings struggle with water waste. And, if we're looking at opportunity, a lot of the solutions, and we'll get into them in section 3, can be implemented in the hallways. So very easy to implement. It may happen if they're doing the capital improvement, as I mentioned, but a lot of these can implement at least the water conservation solutions at any time without any major interruptions. However, again, you're starting to see a picture here where clearly their roadblock until now has been cost. And, we, again, with the plumbing company I had operated my previous career, we operated in, say 300 or 400 different buildings. High-rise service was our specialty, and we saw no connectivity. I mean, the majority of these buildings were 1960s, 70s, 80s. Toronto market is a more mature urban environment, and there's just no kind of control or connectivity here. And as I mentioned, I believe it's primarily due to the costs associated with some of these BAS. I mean, they just wouldn't show up in an asset of this type. So that kind of concludes section 1. That's really about looking at the market, identifying the underserved market. Section 2 here now is trying to get a better look at, okay, we know the issue, how do we solve it, and what can be done to provide more value to these building owners. So if we dive a little deeper now into the 2 roadblocks or the current options that we're seeing, which play on some of the earlier slides. As I mentioned, we're going to see consumer products that were really part of the smart home ecosystem. They're built and designed from the technology to the apps for a home. Single, 3/4, 1-inch line coming into a house, very controllable environment. There's no cooling towers, there's no boilers. They may have a small hot water tank, a furnace, maybe a little boiler for a hydronic system, but fairly simple and straightforward domestic systems. The challenge about taking the consumer product into the mid-market is that, again, the consumer products are really a single point use. There isn't multiple shutoff valves, there isn't multiple sensors, there isn't that scalability, and most of the products we see are really around leak detection, which, as you can see just from the 2 examples earlier, a lot of people in the mid-market, commercial market in general, I mean, of course they care about leaks and nobody wants a disaster, but it's certainly not top of mind for projects and solutions that they're looking for. And so, that's the main reason why those products and solutions don't play into the mid-market. Again, on the other end of the spectrum, we'll have the building automation system, which are amazing, very sophisticated, could do a number of things, but they do come with a very high cost. Even worse, I'll say, you need a specialized mechanical contractor to implement these technologies. There's only a number of vendors to really look at for the installation, and so both upfront the costs are quite high, and on an ongoing basis the costs are very high. And so again, we used to see clients that they may have sort of a light version of a BAS controlling some of the HVAC elements, but are just petrified to call in the contractor to make any changes to it due to the cost that they incur to have a service provider out there. And so these are really highlighting the reasons why they're not making their way into this mid-market. And so the obvious next question is, so then what does a perfect solution need to look like? And so we've kind of fragmented this into 4 sections, each of them equally as important as the other, because they all just play into what the arrangement needs to look like to actually provide some relative value. And so number 1, of course, as I've mentioned a number of times now, a low-cost hardware solution is an absolute must. Again, it's quite easy to find nowadays with the reduction in technology costs. It's exponentially being reduced. And so just having something that's not only low cost upfront, but as I mentioned earlier, low cost on an ongoing basis. And that's simply achieved by empowering the entire community of service providers to be able to manage and deal with this equipment. It doesn't have to be super specialized and take 1,000 hours of training to get onboarded on how to implement this. And so that would unlock the requirement for this market. Number 2, as I've touched on, it needs to be scalable. When we implement designs, they may be a small application for a huge building or a large application for that same building. And so having the flexibility to grow and shrink these applications is just again an absolute requirement when we're designing stuff for clients looking for these solutions. Another item here that was super important for me, particularly with the plumbing background, was just simply the ability to connect to and communicate with anything. And so, if we look at the options of plumbing fixtures that can be connected to something, it's 3 basic items. You have actuated valves from a number of manufacturers. You'll have water meters, either simple pulse meters all the way to revenue grade ultrasonic, and then you'll have the sensor category, which is very wide. You'll have temperature and pressure, a little more obvious, but there's flow meters and water quality sensors. I mean, I saw a couple weeks ago there was a student at a university who made an ultra low cost lead sensor, which I thought was incredibly interesting, obviously due to some of the regions and states that have had really bad water quality issues when it came to lead. And so having a platform that can connect to anything keeps it a little more future-proof. It can evolve and grow and implement new solutions and arrangements as new sensors come out, because we know they always do. And then the 4th here, a little more obvious, the arrangement needs to be easily retrofitted. Obviously works in new construction under nearly any circumstance, but being able to be retrofitted into an existing building, primarily for the reasons I mentioned earlier, is that a lot of existing buildings have already experienced or acknowledged an issue and would love to resolve it, but the arrangement needs to be able to be easily implemented in an existing building. And so to just kind of summarize the different needs and challenges and some of the applications that would be presented to different asset types, I've listed a few here. So, if we look at hotels, their leak detection's quite high for them. The fear of, having very short-term occupants or guests have to be displaced due to some kind of leak or rooms not be available is a really big issue for their business. And so we find that, leak detection, reducing water waste, and then the ability to just remotely close water more efficiently is sort of their items that they're looking for. And then some of the others here we've already really gone over. The plazas is on metering applications, multifamily looking for OPEX reductions. And so there's a really wide variety of different asset types. And that's why it's so critical for us to understand the needs and challenges, not only, for a building that's 12 stories, but what is the ownership of that building, right? Is it a hotel? Is it a multifamily, a condo, or a rental? I mean, even those think of dollars and challenges very differently. So just an item here that's very important to keep in mind. And so the last section here, which again, hopefully provides the most value, is going to take a real deep dive into some of the applications in the domestic system. So if we look at all of the distribution piping that goes through a building, I'd like to kind of take you guys on a journey from when water enters the building, how it's distributed into headers, down into the risers, how the hot water is then collected and recirculated back to the boiler plant, and then a few general areas, sump pumps, mechanical rooms, etc. And what we're really going to look at is one slide with the traditional design drawing, a lot of manually operated equipment, and then how the IoT equipment is overlaid on traditional, very good design, but to really help elevate it into the next chapter. So, of course, we start in the sprinkler room. We're going to have a main come in off the street. It'll traditionally go through a water meter or a bulk meter, house meter, as they say. It may or may not have a bypass around just for service. And this really belongs to the region or the city for their billing application. Now, downstream of that, the next device in line or the next product in line, in almost all regions now, we're seeing the backflow prevention requirements are becoming more and more strict, and we're thankful for that. That's a one-way valve to make sure that water enters the building and has no way of being back siphoned out to the street, causing contamination. And so that would be the immediate next device in line. Next in line, in most of the applications, commercial buildings that we see now will have some kind of water quality product. It may be just a simple strainer. It may be a more sophisticated strainer, which is what's on the detail here, or it may even be, softening equipment. There's some, areas, of course, that will need to provide water softening equipment to make the water adequate for the building. And next in line would be a booster pump package. And so one thing I forgot to mention, as we go through this, on the right side here, I'm going to use this sort of 28, 30-story building that has a low pressure zone and a high pressure zone to relate some of the applications and designs here and details. So just keep in mind, that's our example building. And so obviously in a building like this, we're going to have a booster pump. Simply its purpose is to take, probably what's 40 or 50 PSI pounds off the street and pressurize it to adequately reach the upper areas of the building. You may need 150 pounds to actually reach the top floor here. And typically midway through, they have to reduce the pressure. And so we'll get into that. But again, we look at traditional design. There's a manual meter. No one really knows what's going on. Building owners may get a water bill quarterly and analyze that based on last year's usage and very reactively making decisions on water waste and overall consumption and efficiency of the building. And so not a very good way of looking at water consumption in real time, if they're even doing that. There's obviously a lot of stuff going on in the building, and looking at water consumption probably falls a bit short on their list of things to do. So having the main meter actually connected, recording in real time the consumption would allow a building owner in real time to more proactively make decisions on, maybe we want to upgrade our toilets or replace flush valves to more efficient ones. And so having that information dashboard recorded, incredibly valuable in these commercial buildings. The next item in line will be the Backflow Preventer. Now, the two things that I usually implement in a design would be to have one of the valves actuated. That would allow a building owner to just shut down the entire building if something catastrophic happened. Of course, in a 28-story building, you'd probably want a few more valves down in the line, so you don't have to shut the entire place down. But a very low-cost, high-value item. It's really a panic button to have in place just in case. Now, the other thing with the backflow preventers is there's two types. One of them, the RP, or reduced principle, has a vent discharge on the bottom of it. And in some buildings, you know, when the main service line is 3, 4, 6 inch, that vent discharge, when it's doing its job, may spill a bit of water and run off to a drain, and you know, everything's fine and dandy. But when they fail stuck open, there's an intense amount of water that can come out of the backflow preventers. And so simply throwing some kind of flood sensor, or as they call a water bug, something below the product. So if the product does fail, there's just an early warning. You can go and shut it down or use the actuator to close it down. Again, you know, low cost, high value. If this sprinkler room's on a first or second floor out into a hallway, we've seen some very awful scenarios of just Niagara Falls coming out of the sprinkler room and damaging a number of units. Now, the next product in line to connect would be the water conditioning or filtration product. And just simply having a pressure sensor before and after would allow you to understand the pressure drop, or the delta P, across the filtration product. And that would allow you to get an indication when the media, you know, needs replacement. Maybe there was a water shutdown or main break on the street, and all of that sediment just came in and plugged up all the strainers. You'd be able to see this more proactively, you know, and attend to it. We see this quite often where these filtration products are just jammed up with stones and debris, and it's really choking up the boosters, degrading the booster equipment, which is obviously not inexpensive. And so again, simple pressure sensors before, after gives you a really nice indication of what's going on across the conditioning product. And then of course, lastly, you'll have the booster pumps. Some of the booster pumps coming out now are unbelievably sophisticated, but again, time and time again, we're not seeing them connected to anything because there's just no BAS in the building, or nobody wants to pay the cost to get them connected. And so simply connecting to them with some lower cost solutions that are doing a number of things in this room makes it more, you know, gives it more of a reason to even do this in the first place. You know, we see a lot of manufactured products nowadays that are smart or connected, but they're a point in a much greater system. And so if you're just getting information from a pump, it's good, but it's not great. You know, if you're getting the consumption and the leak detection and the ability to shut water and the pumps, it begins to become a more cohesive platform to actually make, you know, these better decisions. And so we just kind of look at the benefits to the owner and the occupants, because that's all that matters at the end of the day. Again, to just summarize, it's the ability to have the autonomy around water conservation and analytics and the data being recorded. It's about monitoring the equipment to make sure that it's functioning properly as designed, you know, that the pressure isn't 180 when it should be 150. You know, having the remote valve control for a catastrophic issue is very valuable for them. But you can also do valve exercising, which unfortunately nobody does. But having a connected valve will now allow you to open and close this valve a couple times a year to make sure that it works when you really need it. And as I mentioned, you know, monitoring pumps, equipment, and then even detecting underground water leaks. In some regions, typically warmer climates, they run the water service up underground into a sprinkler room, they meter it, but then they go back down in the ground. And we've seen a number of buildings that'll have small pinhole or some kind of corrosion at an elbow, and it creates a huge kind of, pothole, let's say, below ground, and the water bill obviously through the roof. And so just having a way to track and detect that. So next in line, we've looked at when water enters the building. As I mentioned in our example, that booster pump downstairs needs to deliver, for example, I'll make up a number, 150 PSI to reach the top floor adequately. And so that's fine. It loses pressure by gravity, hits the top floor header, and then distributes beautifully to the upper half of the building. For the lower half of the building, having 150 out of a pump and maybe 130 by the time it reaches that upper header on the low zone is still too much. And so it's a very common design that we see nowadays, where they'll just simply reduce the pressure with a pressure reducing valve. You can think of it as a transformer for those that are comfortable with electrical. We're just taking a high pressure, changing it to a low pressure, converting a voltage, so to speak, and then distributing it at the correct pressure into that zone. In our case here, zone 1, we'll call it. And then you're now prepared a hot and cold water supply at, say, 60 PSI to be adequately delivered to that low pressure zone. Now, because you've lowered the pressure, you still need to recirculate hot water, and so you can't bring the hot water back to the main shared boiler plant because that's the high pressure side. And so typically they'll recirculate the hot water right back into this PRV closet or this mechanical room. And they reheat that water with a sidearm heater, a plate and frame, electrical. There's a number of different products out there. But the idea is you supply 125 Fahrenheit water, it distributes through the risers, hot water is recollected and placed back into the supply line in this room, and again, as I mentioned, reheated. It creates that loop with a small circulator, and that's what you're seeing really on the detail here. So we have a hot water supply with 2 PRVs, a low flow and a high flow. Same exact thing on the cold water. And then simply for the hot water, we have a return line with a pump, hopefully a circuit balancing valve, and then it dumps back into the supply. And so again, it's really great design, looks really good on paper, but as we see in real life, these pressures and temperatures and flow rates just get all out of whack due to a lack of knowledge and a lack of maintenance. And so when we look at this, it's really an application of how do we manage, absorb information and control these conditions. For me, these are, absolutely paramount in a domestic plumbing system, particularly in larger buildings, monitoring pressure, temperature, and flow rate. If we can keep pressure, temperature, and flow rate at the required engineered design settings, these buildings will operate incredibly well. Their piping systems, whether it's copper or Aquarise or PEX-A or whatever products are out there nowadays, you don't have to be worried about anything, knowing that the pressure, temperature, and flow rates meet manufacturer recommendations. And particularly, for the engineering community, pushing boundaries and experimenting with new products are great, but you really gotta, they have the liability at the end of the day if system conditions are out of whack, and they're typically the developers are pointing the fingers at engineer or contractor or manufacturers. And as I mentioned, time and time again, we're seeing these conditions are just brutally out of spec. So when we look at a PRV station like this, it's really about monitoring first the pressure output. So again, replace the typical manual gauge that is probably broken anyways with a pressure sensor, and just simply having an alert that says, if you go above 60, this valve should shut off if you have an actuator, or at least get the alert, to understand. We were looking at data last week, and these PRVs are just fluctuating like crazy overnight. And so, they need attention. They need adjustments here and there, but maintaining the right pressure is incredibly important. The next item in line here is temperature. So very frequently we see that buildings are supplying temperatures that are too high, even though residents love it. The occupants very happy with hotter water because most people complain about a lack of hot water. But temperatures, into the 130, 135 range, scalding concerns aside, on the hot water system, it just destroys the piping. You get erosion, you get pinholes. We used to see 5, 6, 7-year-old buildings, and all of the recirculation header is just, paper thin. And it was because the little circulator there has no brain. It just runs 24 hours a day. Again, on paper, there was a circuit balancing valve there. Great idea. But unfortunately, what happens in real life is people tamper with things. A CBV has no visual indicator on the flow rate, and they're very hard to balance. You need gauges, and as I mentioned, no one's doing this. So having a way to understand the pressure or the temperature delivery is very easily done. Throw out the manual thermometer and use an inexpensive, off-the-shelf, readily available temperature probe. And then the last one here, which I kind of touched on there, was the rate of flow on the hot water system. So obviously the cold water goes through a PRV, it distributes to the header and the risers and then terminates, doesn't need to be recirculated. But the hot water recirculates via the pump back to the zone so that the occupant furthest away from the source of heat is getting hot water right away. It's basic recirculating principles. Again, what we're finding very frequently is that the manufacturer recommendation might be 2-3 feet per second, or the engineers, and you look at buildings that are 5, 10, even 15, we've seen feet per second, and it's a shame. They've spent all this money and put in all this piping and equipment, and it's all just being shredded from the inside out. And so, we've seen very clever clamp-on sensors that can record a flow rate. And so just putting that on with a visual indicator would allow a service provider, the manager, to make sure that the flow rate is at the design condition. Now you can actually control it. As I mentioned, actuated valves, dime a dozen. The actuated valves you can find can actually be put into a certain position. So not just on or off, 0 to 100%. You can actually set them to 10, 15, 20%, and that would relate to obviously a flow rate. They call it a CV. So you're just balancing now digitally the recirculation flow rate as opposed to relying on manual equipment that surely has been tampered with. And so you can also now amplify the benefits of maintaining the right flow rate by saying, during off-peak hours, we don't need full rate of water flowing through our system. And so you can throttle it down just a touch more. Obviously, you can't bring it to a complete stop because you'll have other problems, but just slow it down to maybe 1.5 feet per second or quarter GPM just to keep the water moving. And that really leads into, again, the benefits here. And you'll start to sort of see these repeat throughout some of the other applications. But having the alerts and abilities to autonomously control pressure, temperature, flow rate, really low cost, super high value for building owners long term. Protecting against scalding and other temperature related issues that I've discussed. Having actuated valves in this room would allow a building owner to shut down half of the building now, which becomes a little more realistic than the main valve down in the sprinkler room. But you could also apply the autonomous valve exercising so that when a PRV needs to be serviced, the valves work, they would just shut down, you do your work, turn it on, all's good. And so that's real, the main values that come from a very simple area in the building. And you can reapply this to the upper zone of this building. We'll look at that in the boiler room. So we've looked at water coming in off the street in the sprinkler room, goes up into an express, gets distributed for 2 halves of the building. The lower half goes through the pressure reducing valve station. And then in both zones, what happens, of course, is it goes through a horizontal distribution header, usually through a hallway, and then splits into its final risers that would serve vertically a number of suites or a number of office floor plates, however the configuration is. And that's sort of the next place that we look to elevate the design. So when we look at, again, a simple detail, hot and cold supply lines, in this case coming from the bottom, feeding up, and the hot water would terminate to a recirculating valve. Again, hopefully a CBV or some kind of control mechanism there to slow down the rate of water now, not only at the main PRV station, but actually along independent lines. You know, the line further away from the suction from the pump may draw less than the riser that's closer. And so there's often this exercise that happens post-construction during the commissioning where you would have to balance all of the circuits. Now, you know, unfortunately, we find this almost never happens. Hopefully it does. But as I mentioned, even if it does, you can almost guarantee some plumbers walked in and tried to use it as a shut-off valve, and now the whole system's out of whack. So as we look into the connected side of things, no change to design, makes perfect sense. However, we just need a bit of information to what's going on along this riser. So there's two primary things to consider here. One, as I've mentioned a few times now, the actuated valve in lieu of the manual valve gives you the ability to shut down for simple service, for emergencies, but then you get the autonomous valve exercising that happens. It's a ton of value. You're just simply extending the useful life of the valve, probably by double. And then the second item here would be to register how much hot water is flowing through the pipe or how much cold water is being used up by the highest using fixtures like toilets. And so, as I mentioned, there's some very simple, readily available clamp-on equipment. It's also become, you know, much more accessible with its lower costs. And so applying this begins to allow us to digitally understand and control and connect to these systems and ensure that all of the conditions are optimized. Now, the last area in this sort of, you know, journey of distribution would be very similar to the PRV station, but up in the mechanical room, or, you know, this could be in the basement, this could be on the roof. Seeing a lot of the newer construction buildings are placing this up on the rooftops. And again, you'll see very light versions of some kind of controls, operating a pump to a boiler, just making sure those are speaking. But when it comes to the domestic side of things, you know, I walked into a boiler room a few weeks ago, and the two thermometers, one on the storage tank, one after the mixing valve, both of them not functioning. And so no one has a clue what anything's, you know, being stored at or being delivered at, being recirculated through. There was no balancing valve. And so again, very simple sensors, readily available, pressure, temperature, flow rate. Apply those into these systems and just ensure that everything's operating at optimal conditions. And so that's what we look at when we look at the connected side. How do we look at recirculated water back to the boiler plant? How do we look at mixing valves, hot, cold, and the tempered water outlet being delivered to the suites? You know, is that thing malfunctioned? Has it not been serviced in a couple years? And you may add some leak detection. Obviously, there's a lot of equipment going on here. And so these are some of the things to connect. Now, these are sort of more general aspects of the domestic system to make sure they're not forgotten. So we've looked at really the main distribution, but some of the other elements that are missed do bleed in to the HVAC side. So in a HVAC system, it's a closed loop system. So, you know, you fill it with water, and it's that same water that just gets recirculated into suites, back to the, you know, cooling tower or heating boiler, whatever the case, and you're just moving that water around as efficiently as possible. There will always be a way to refill that system. They call it the makeup water supply or fresh water makeup. And this is that typical detail here. So we'll see a couple shut-off valves, a pressure regulator to automatically fill the system to a certain pressure. or make up that water as it may be lost. And then, in, again, most regions, you're going to have a backflow preventer because a lot of these systems are full of glycol or rust inhibitors. And so this is, straightforward freshwater makeup supply to a closed loop system. When we look at connectivity, for me, this is a really low cost, high value item, and I'll give you a few reasons why. So what typically happens in a closed loop system, if it's functioning normally, there's no leaks, there's no shutdowns, nothing unusual is happening, there's really no water being introduced to the system in a substantial way. You might have, point something of a cubic meter a day just naturally being lost, if even. But obviously, if the system's functioning normally, no water would be introduced to the system. And so simply having a meter applied to this arrangement, which we're seeing more and more frequently, a manual, regular water meter, you would be able to, based on the IoT information, just create a very simple alert that says, if water consumption exceeds half a cubic meter, we probably have an issue. At least we can close it down. It may be a small leak. We see fan coil units, like a vertical fan coil unit that has an A coil, water supply above a fan, but it's sitting above a condensate pan. And if one of those little copper tubes in that A coil has a small leak, you usually don't even see it. It just lands right into the condensate pan and out to the drain. The challenge is you're losing water, which isn't cheap. You're losing chemicals, which are awfully expensive. And so if you see or registered some kind of small leak through this meter, for instance, on filter replacement day, you can have them look out for any kind of leakage, knowing that it's there far more proactively than really anything else. Because ultimately, in that case, you'd be waiting for water damage, or your chemical contractor would tell you that we're using way more chemical than normal if they even brought it to anyone's attention. And that kind of leads me into my next value here, is for those chemical contractors. So they really rely on some kind of water meter or information to adjust the dispensing units if they're doing it manually or automatically. But they have to dilute the closed loop system with a certain ratio of chemical to water. And so, it's very important for them to understand if water has been lost, maybe there was service or a shutdown or a leak, to understand how much water was lost during that event so that they can refill the ratios accordingly. And so again, very simple ability to have that information online would ultimately let the chemical contractors do a better job at diluting the system. Excuse me. And then the last thing on the HVAC side, similar to the domestic risers, you're going to have a supply return, which is the detail on the right here. And so we see always that these supply return lines are provided with a manual butterfly valve. And again, simply having an actuated valve versus a manual valve promotes a ton of value for building owners, primarily from just typical service and maintenance. But of course, if there was some kind of major leak, these type of leaks can be quite catastrophic. So having the connected valves there would be very important. And so that kind of sums up, the high level look at how IoT is really elevating design standards, why we're, big advocates of creating connectivity around domestic plumbing systems. And, as I mentioned in the earlier slides, at the end of the day, these solutions need to be open-ended and give service providers, solution providers, engineers, building owners the freedom to get creative. Everybody's got different problems, and we need a way to solve those issues. If I could paint a beautiful picture of what this really should all look like, if there's an issue, it gets reported automatically. Parts are ordered from a supplier because we know which piece of equipment is deployed in the field. All of the coordination for shutting water could be done very seamlessly. And at the end of the day, just promotes a much more efficient building, utilizing its resources much, much better. So thank you very, very much, everybody from CIPH. Absolute pleasure to host this presentation today. I'll throw it back to my colleagues and everyone else, and looking forward to doing this again. Thanks very much.
Thank you, Adam, and thank you for a great webinar as well. If there's anyone with any questions, if you can please write them in the Q&A box. We'll be accepting a few questions. So we'll just give everyone some time to type out their questions.
Awesome.
Okay, it doesn't seem like there's any questions coming in. Thank you, everyone. And if you do have any questions afterwards, please feel free to send us an email, and then we'll just forward that over to you, Adam, and we'll get back to anyone with questions. So thank you, everyone, for a great webinar, and this concludes our webinar for the day. Thank you.
Thanks.